So in the previous part, we discussed the subgradient descent algorithm for minimizing the loss function in the L1 norm regularized linear regression. And now we are ready to discuss the ISTA algorithm, which you can use to minimize the loss function in the L1 norm regularized least square problem. So let's see what this ISTA algorithm is. So we have a loss function in the L1 regularized least square. Loss is equal to L2 norm of y minus phi times w squared plus lambda times L1 norm of the parameters w, where lambda is just some scalar between 0 and 1, where lambda gives a relative importance to the regularization term relative to the objective or the loss function over the data set. So the smaller the lambda, the lesser the importance for this regulation term, and the higher the value of the lambda, the more the importance this regulation term gets. So we have seen that we can use the subgradient descent algorithm to minimize this non-differentiable loss function. Furthermore, as we discussed earlier, this is a convex function. The loss function or the objective function is convex, since any norm is convex and sum of two convex functions is also convex. So this term is differentiable, whereas this term is not differentiable, and that's why, like in the previous part, we derived the subgradient descent algorithm to minimize this loss function. And now we are going to discuss an algorithm known as ISTA, which tends to have better rate of convergence as compared to the subgradient descent algorithm. So ISTA typically have better convergence, better rate of convergence as compared to the subgradient descent algorithm. So we are now ready to begin the discussion about the ISTA algorithm and to actually derive the update equation for the ISTA algorithm. So the first step in deriving ISTA algorithm is to discuss a mathematical concept known as majorization and minimization. Majorization and minimization. So the majorization and minimization is a mathematical concept where we optimize a loss function, where we can denote the loss function as j of w. We minimize the original loss function by replacing this loss function with another easier to minimize loss function, which we can call g of w. So instead of directly minimizing this loss function g of w, we minimize an alternate loss function g of w, and at every iteration of the algorithm, the majorization minimization algorithm, we compute this function g such that by minimizing g at every step of the majorization minimization algorithm, we minimize the original loss function j of w. And now in this part of lecture, we will discuss the majorization and minimization in detail, and we will see how can we use the majorization minimization algorithm, or MMA for short, to minimize the loss function in the L1 norm regularized least square problem, which is norm of y minus phi times w squared plus lambda times norm of L1 norm of w. So majorization and minimization is used when the original loss function is either too complex or difficult to minimize directly. So in this particular case, we have this loss function, or the objective function of the optimization problem is not differentiable, because this term is not differentiable. So using majorization minimization algorithm, we can replace this objective function or the loss function with another loss function, g of w, and this g of w has to have some properties, right? We'll discuss what those properties are, but it needs to have two important properties, which we'll discuss in the next part, in the next part of the lecture. If this function g satisfies those two properties, then by minimizing this function g of w at every iteration of the algorithm, will ensure that we minimize the original loss function L of the original loss function L of w. So in a nutshell, what majorization minimization does? So majorization minimization replaces the original optimization problem which may perhaps be complex or difficult to minimize directly. So this problem can be complex, like too complex optimization problem, or maybe just difficult to minimize. As we see in the L1 regularized linear regression, this term is not differentiable. So perhaps we can replace this objective function with a differentiable objective function, and then by minimizing that differentiable objective function, we can minimize the original objective or the loss function. So the majorization minimization algorithm replaces the original optimization problem by a sequence of optimization problems, by a sequence of easier optimization problems which are perhaps easier to minimize, and that's why we'll do that. Otherwise it wouldn't just make any sense if those optimization problems are not easier to minimize. So it takes the original optimization problem, and instead of directly minimizing the loss function, the original optimization problem, it replaces that with a sequence of easier optimization problem, and by minimizing the sequence of loss functions in the resulting sequence optimization problems, we obtain a solution that minimizes the original loss function. So these optimization problems or these loss function are perhaps easier to minimize, and that's why we'll discuss the MMA algorithm. Otherwise, if this is not easier to minimize, then it just doesn't make any sense. So now in the next part of the lecture, we'll see what actually the majorization minimization algorithm is, and how can we use the majorization minimization algorithm, how can we use the majorization minimization algorithm to minimize our original loss function for the L1 norm regularized least square problem.